Hello students, how are you? Today is the third video of my YouTube channel and I assure you this is the first time on YouTube that anyone have taken all the series and parallel combination of whole physics in only one lecture. So let's start. Series and parallel combinations, the first I have taken is the resistance, electrical resistance, and you will be well knowing the series combination of the electrical resistance is simply the additions of the same. That is, if one resistance is R1 and another is R2, then R effective is equal to simply algebraic addition, that is R1 plus R2. Now the parallel combination of electrical resistance is 1 by R effective is equal to 1 by R1 plus 1 by R2, and when we shuffle it, it becomes R effective is equal to R1 R2 divided by R1 plus R2. Second, inductance. The series combination is L effective, that's the is equal to L1 plus L2. The parallel of the inductance combinations are 1 by L effective is equal to 1 by L1 plus 1 by L2. That is, it is same as electrical resistance. Third, time constant in boiling of water. This is very important because it's often asked in entrance examination. In time constant in boiling of water, in series combinations, T, that's whole time, will simply be the addition of the individual times, that's T is equal to T1 plus T2. In parallel combinations, T is equal to T1 T2 divided by T1 plus T2. That is, the time constant boiling of water is also the same as resistance. The first, I will assure you that the first five are all the same but the electrical resistance. That is, the series will be the simply algebraic addition of the individual resistances, and the parallel combination will be the algebraic addition of the inverse of the resistances. Now the fourth is thermal resistance, and you must know it's not the electrical resistance, it is a thermal resistance, and which is equal to L by Ka, where L is the length of material through which heat is flowing, K is the thermal conductivity of the material, and A is the cross-sectional area of the same. Series. In series combinations, this is simply equal as electrical resistance, that is R1 plus R2, and in parallel it's equal to R1 R2 divided by R1 plus R2, or we can reshuffle it into 1 by R effective is equal to 1 by R1 plus 1 by R2. Now fifth, when ends of pipes are connected in Poiseuille's equation, R is equal to 8 eta L divided by pi R4, where eta is the coefficient of viscosity, L is the length of pipe, R is the radius of the pipe. And in series combinations, it's simply written as R1 plus R2, and in parallel it's written as 1 by R1 plus 1 by R2 is equal to 1 by R effective. Now, what is the trick? The trick I have formulated for my beloved students is that only 3 combinations you have to remember which are not same like electrical resistance, that is, which are inverse in that. For example, in electrical resistance you have seen that resistance are in series are simply the addition, algebraic addition, and in parallel they are inverse of the individual sum of the inverse of the individual resistances. But in these three, that is springs, capacitances, and bulbs, springs, capacitance, and bulbs, in these three cases you have to go through the inversion. That's in series you have to use the parallel like combination in electrical resistance, and in parallel you have to use the series like combination as in electrical resistance. Springs in series, you have the K effective is equal to K1 K2 divided by K1 plus K2, or 1 by K effective is equal to 1 by K1 plus 1 by K2, and in parallel K effective is equal to K1 plus K2. Now you have seen that these are inverse as the last or former 5 examples. Capacitance series 1 by C effective is equal to 1 by C1 plus 1 by C2, parallel C1 plus C2 is equal to C effective. And in bulbs, in series combinations, the power 1 by P or power effective is equal to 1 by P1 plus 1 by P2 plus 1 by P3, where P1, P2 and P3 are the power of the individual bulbs. In parallel, it's equal P is equal to P1 plus P2 plus P3, and these are only the 8 combinations in whole physics you have to remember. And what is the trick? Trick is the most important part of this, which I have formulated for you, and it is only available on this You Study Tube channel. The trick is that you have to remember that the springs, the capacitance and the bulbs have inverse combinations as the electrical resistance, and the former ones, that is, I have written the time constant, the electrical resistance, the thermal resistance, Poiseuille's equations, and pipes, they have all the same like electrical resistance. Thank you, students. So please like, share and subscribe my channel, and anyone wanting PDF or images of today's topic can comment in comment section box, and I will provide him link for the same. Suggestions are also welcome. Thank you.